For those of you just joining us, welcome to our second session of our Open Science webinar series, where we are aiming to break down the open science knowledge barrier with David Miller and Zach Loomis from the Center for Open Science. And with that, I will pass the mic over to David, who will start the discussion by presenting what open practices can span the length of the project and where to find information on how to do them. And stop sharing my screen.
Thank you so much. And would you please give me permission for video?
Yeah, there you go. Sorry about that.
Thank you so much for that kind invitation. Or introduction. I'm going to share my screen in a moment, but Zach and I are very happy to be talking this morning or this afternoon, wherever you may be logging in from, about overcoming the knowledge barrier. So with one moment. I will begin with that. So I want to let everyone know what's going to be covered over the course of this webinar. Very brief and superficial focus on what we talk about when we discuss open science, with an aim towards transparency and reproducibility of the scientific workflow and how that connects with the entire research lifecycle. Zach will be talking specifically about what tools exist to support open science with a focus on the open science framework. And then we'll finish up with a consortium, a large group of resources for where to find more information. I want to emphasize one point about what this webinar will not be. This isn't going to be about why you should participate in open science. I love giving those webinars, but most of this will not cover kind of the evidence of the need for it or a demonstration of the practices, so much as to instead focus more on what these practices are and mostly where to go to find more information. So we're happy to focus on that. There's going to be one exception to that. I can't quite help myself to talk about a couple of points on where these become quite important. So first we'll be sort of covering again what I said, what COS means when we talk about open science, a couple of important tools, and then resources for finding more information. When I talk about open science, I'm really talking about three particular practices or initiatives, and it's making data and code available to the greatest extent possible so that robustness can be verified, computational reproducibility can be checked, and the data can be reused for different purposes beyond those from the original research question. Making research materials available to assist replication efforts. Those include both digital materials such as instruments and questionnaires and the like, as well as working in the physical and life sciences on persistent unique identifiers and repositories for those items and for those research materials. And finally, we have a focus on pre-registration in order to address the file drawer and address the known bias towards statistically significant or large effect sizes. The purpose of this is to make clearer distinctions between two different modes of research that can be quite easy to unintentionally conflate. When we talk about open science, we think about the entire research lifecycle and recognize that much of this is often lost. The published final report represents essentially the tip of the iceberg of what in many cases is years of work that went into it. And here at the Center for Open Science, where we build and maintain the open science framework, we think about the process one goes through to plan a study, to conduct and analyze it, to collect the data, and then early dissemination through preprints. A lot of that work deserves to be captured, to be preserved, and the OSF is really designed for that purpose. And pre-registration in particular is one we bring up because the best time to start is obviously at the beginning of a project. The benefit of helping one prepare for the study through planning it, obviously starts at the beginning. So what pre-registration is, it's the submission of a detailed study plan to a public registry. And the two types of issues that it addresses is it helps to open the file drawer by clarifying precisely how much work is conducted in any given span of time in a discipline. And it can also make that distinction between hypothesis testing and hypothesis generating research more clear. These two modes of research are equally important, but they are quite distinct. When one is in the mode of confirmation, we're really talking about traditional hypothesis testing and minimizing false positives. When we're in the mode of exploration, this is the data-driven discovery that's very motivating and very exciting. And we do want to minimize false negatives in that point. We don't want to miss something that could be really, really worth following up on. But pre-registration is a process of keeping these two modes of research distinct: the planned confirmatory work and the unplanned discovery. One of the tools that we built on the OSF to enable this is the OSF registry. And that walks individuals through the process of creating a detailed analysis plan, providing prompts and information about the degree to which data exists for a study, and gives detailed prompts about what needs to be included in an analysis plan, again, in order to make that distinction between planned analyses and unplanned analyses more clear. The result of that is a completed registration. Many of them are embargoed, but they do get submitted to the registry, so they become publicly discoverable after a point of time. Now, there is a lot to unpack about the process of registration, and I started with that just to emphasize, just to clarify what some of the important big points are. But I expect if that's the first or second after you've heard about it a few times, you probably have lots of questions. And one of the main points of this webinar right now is to point out the different types of resources that exist for each of these practices. So a couple of resources that will meet that goal. You can discover pre-registrations on the OSF registry. That connects to registries that, again, are on our platform on that registry, but also to external registries, clinicaltrials.gov, Research Registry, and a few others have content from many different disciplines discoverable through that interface. So it's an open registries network so that you can find examples of study plans or analysis plans, almost regardless of what field you're in. There's a curated information hub at cos.io/prereg that has FAQs, that has examples. All the links that we'll be talking about when I talk about pre-registration, almost all of those are included on that detailed information hub. There are lists of up-to-date literature reviews about the need for processes such as pre-registration and the evidence of its effectiveness or lack thereof in different modes. And so this evidence hub can be very useful for, again, understanding the need and the effect of processes of all open science practices, but in particular pre-registration. And finally, sometimes the most helpful examples are published, are examples that show up in the literature. So each one of the items in these Zotero libraries have an open practice associated with them. The links that are provided on the OSF project that I shared in the chat earlier get to a couple of different Zotero libraries. This one right here shows badged articles, those that have an openly available data set, openly available research materials, or pre-registration associated with them. And that can be very helpful for both seeing what the pre-registration looked like and looking for ways to report the results of pre-registered work, which is one of the most important aspects of that workflow. And with that, I'm going to hand it off to my colleague, Zach, to talk about the OSF.
Thanks, David. So as David mentioned, I am Zach, and I'll be talking about the Open Science Framework, which you can access by just going to osf.io. If you don't have an account, it's easy to sign up. And if your institution is a member, you can also sign in with a single sign-up. So the goal of the OSF is to cover the entirety of the research lifecycle by providing, as David was talking about, OSF registries, so that in the initial stages and planning of a research project, there's a place to put a registration. but it also acts as a repository so that materials and data that you gather are stored in a centralized location. And then we also facilitate preprints, which is a way to put results out before necessarily going through peer review. The main unit of organization for the OSF is a project. And so here we have an example of Mini Babies, which is a large-scale collaboration in developmental psychology. That is a really great example of how to maximize some of the features of an OSF project. So on this, you can see that there is a location for files to be stored. This operates similarly to a file directory on your computer where you can create projects to organize different materials. You can upload just about any type of file, and it will also render when you click on it in the OSF so that you can preview things without necessarily having to download them onto your machine. And essentially, and also offers storage locations around the world so that if you need to have your data stored, for example, in a certain location, we can facilitate that. Another way to structure a project and build out from it is to have components. And so similarly to a folder structure, you can add subcomponents to an umbrella project that lets you organize, for example, different branch projects, for example, that they've done in the Mini Babies project, where they have different collaborations, each having their own component that still connects to the main umbrella project. But on a smaller scale, you can imagine having a different component for your materials, for your data, for your analyses, so that these can be organized in a way that's accessible for others. And you also can add contributors to your components at any level. The benefit of having components is that at each level of a component structure, you can control which contributors have access, as well as which ones are public or private. And so you can see here that the Mini Babies project is itself public, and so anybody can find it by going to the link at the bottom of the slide. But if there is something that is perhaps ongoing work or something that is necessary to keep private for any other reason, you can create a subcomponent that stays private and that you give metered access to select contributors. As I mentioned, OSF is intended to bring together the entire research lifecycle. And so the project integrates with both registries from the beginning to the preprint servers at the end. And so if we go back to the project view, you can see in the top bar, there's a button for registrations, which would take you to any registrations that are associated with this project. And when you go to upload a preprint to share your manuscript, you will have the option to connect it to an existing project or create a new one if you'd like. And so it comes all together across the research lifecycle to go from registration through data collection and materials design into the preprint sharing. And so with that very, very general overview of OSF, and there's plenty more to explore there. If you'd like to, I would encourage you to just go to OSF, make an account, have a project that you just experiment with to see what works for your research workflow. Now I'll talk about what resources there are that you can go to find more information about OSF and other transparent and reproducible practices. So starting with OSF, we have a fairly expansive help guides. For example, starting with our just menu of best practices, we can go to explore a data management plan. If that's something you're not familiar with, I would encourage you to explore it. If we go to that article, we can see that there's an overview of the questions that you should be asking yourself when planning out what will happen with your data after you've collected it. And it just gives a very approachable overview of how to go about conducting transparent and reproducible research. And another example is making a data dictionary. I chose these two because data documentation is something I have become passionate about, and so they are very poignant for me. But they are things that are not necessarily formally taught in many disciplines, and so they're a great place for people who are new to open science to get started with some instruction. Another opportunity to learn more is to sign up to attend webinars like this one at cos.bio/webinars. You can sign up to receive alerts. And if you also just go to that page, there's a list of upcoming webinars as well as past ones, many of which have recordings that you can view after they've already occurred. And this is a way to get the kind of presentation of information like this that will also connect you with additional resources. And I like to lead with this quote because we're presenting you with a fair amount of information and resources, and it can feel like it might be kind of intimidating to look at those things. And so while it does take effort to think about your research in a different way and organize it so that it is reproducible, you will be the principal beneficiary of that work. If you think of completing a project and 6 weeks later needing to revisit it because an editor has requested some change to your manuscript or an additional analysis, creating something like a data dictionary or a data management plan makes it clear to your own self how to re-engage with work that you have kind of thought of as complete. And thinking of an even longer time span, 6 months, a year, even farther out, it's incredibly helpful to your own self to be able to go back and have immediately accessible context for what you were doing after you've already completed several other projects in the meantime. And so I would encourage you all to explore more. And with that said, I'll pass it back to David to talk about some additional resources.
Thanks, Zach. I'm going to start with the Open Scholarship Knowledge Base. This is a large collection of resources really designed for that problem of overcoming the knowledge gap. The first time one hears about open science, it can feel like a gigantic wave crashing over you with all the different possibilities. The Open Scholarship Knowledge Base is designed in a couple of different ways, or a couple of different dimensions that I'll point out in a moment, to get the right person to the right information at the right time. So I'll be providing links to this also in the chat. The first link that I shared at the beginning has a curated list of all the resources that Zach and I are presenting on. So do take a look at that afterwards. But I want to give you a preview of what these things are and how to navigate them and what types of resources are available on them. First and foremost, the content and information available on OSKB, the Open Scholarship Knowledge Base. The first way it's organized is through groups, and this is one of the most powerful tools in OSKB to make connections and to build community between researchers, between educators, between groups of policymakers that are really focused for finding the information that is relevant to them. So I'm going to focus first on the researchers because that is the target audience for this webinar. But if others join other times, I'll give other examples. But this is the researcher hub that has a list of resources that have been submitted and curated by this community for this community. And the first one that I think is that I'll highlight is really quite impressive. It's a tutorial for how to create a data dashboard using a tool, a process called Shiny Apps, which is just a kind of fancy way to say a programmable, deployable web web app. So these data dashboards can be great visualizations to simply use internally to see what projects you're working on, or to give a public face to any ongoing research project. So I highlight that one in particular because it's one of my favorite ones I've seen recently. But it gives a step-by-step guide for what a data dashboard is, how to deploy a Shiny app, and other resources related to that question. The other major dimension that OSKB is organized in is these collections. These are resources that specifically apply to, obviously, if you look at the screen, analysis, data transparency, educating others, or getting published or working on more reproducible practices. I'll give an example here to the reproducibility collection. So this reproducibility collection, again, highlights items that have been submitted by those various communities, but for one of these purposes. example that shows up first is the 7 easy steps for getting started with open science. And that's, if you've just heard about this crazy open science thing for the first time, the first resource that shows up on that list is a good introduction to several of these first steps that are worth taking. I'm going to now go into more external resources that are available that we're aware of and that we've curated, again, for this community, for this for this webinar audience who's really curious about how much information there is out there and where to find more and where to get to the right information at the right time. The first one I'll highlight is the UK Reproducibility Network. UKRN is obviously a geographically focused network of researchers that are that came together to address these open sciences challenges and benefits. Obviously, a main one is education and getting good instructions and information together easily and accessibly. And I'm a big fan of the primers that are available for various bits of content that UKRN has put together. My favorite, if you will, would be the Preregistration and Retrospective Reports one, but there are great primers, and sorry for all the authors of the other ones that I didn't call out, but all of these give great resources if you're curious about getting started with preprints, open access publishing, some open code and data sharing issues. Some of the best ways to engage with open science are self-directed learning practices, and we're living in kind of a cliche, but kind of a golden age of those types of materials and resources that are available. There are a lot of very useful, very easy to begin online tutorials, particularly for getting started with scripted data analysis. I'll particularly call out the one provided by Daniel Lockins that gives a great overview of statistical issues, so improving your statistical inference and common pitfalls that one could fall into. And that does give a basic introduction to using some of the tools available. But then branching off of that, there are even more available that really help you get started with R and getting started with a scripted analysis package. The benefit of using a scripted analysis package, as opposed to kind of the old school drop-down menu of selecting your statistical test, is that it can become very clear and precise exactly what analysis was conducted, what data went into it, how it was processed, and then what tests were run and what those results are. It's just a way to more precisely and accurately document the data collection, cleaning, and analysis pipeline in a way that's otherwise lost with more traditional software tools for statistical analysis. Links to all 4 of these, again, are available on the OSF project that I shared. These are 4 that I can vouch for that are approachable. I was not a computer science major, and they were approachable to me, so I can sort of vouch for that in that sense. And they give you the sort of basic tools to get started with these beneficial workflows. Another set of resources and information that I can vouch for also is the NIH Clearinghouse for training modules for enhancing reproducibility issues. This was created in response to a call for proposals that NIH put out. And there's about 3 or 4 dozen of them that are available across the suite of packages, workflows and processes that deal with data collection, experimental design, and reproducibility. Again, apologies for playing favorites, but I'll point out one that, again, I've taken and used and I found quite helpful. Aaron Carroll is a science communicator, does a lot of great work in science communication, and the modules that he provided in experimental design are really quite appropriate for a number of different disciplines. As you might imagine, these NIH modules are very focused on life sciences and clinically relevant or pre-clinically relevant research issues. But to be quite frank, a lot of the process is widely applicable. And so I can vouch for this one as being appropriate for a pretty diverse audience of researchers. There are a number of workshops and trainings that are available. I'll point out 2 and 3. The Carpentries is collaboration is an umbrella organization of data and software trainings. What their method is to send, and I'm not sure, we're doing everything virtually these days, of course. Traditionally, they'll identify a data carpentry trained workshop provider that's nearby to you geographically, send them to your department or send them to your university, and hold a half day or a 1 day or a 2 day workshop to cover the data analysis or the software issues that they're trained in. And it's a great resource for getting started on some of these reproducible workflows and practices. I'll do some shameless self-promotion and talk about some of the offerings available from the Center for Open Science, but that page, cos.io/training, again, there's a link to that in the OSF project I shared. But that provides specific training on reproducible practices using the OSF as an example. FORT is a framework for open and reproducible research training, and it provides educators with, again, a framework for showing how these practices can be engaged with in the classroom. I think one of the most powerful movements in the open science community are these grassroots communities that come together. Sometimes one might feel like they're the one person interested in this in the department, and it's just very gratifying to see others who are sort of grappling with the same issues or who have experience with some of the coded languages or some of the issues that come up with registration or data cleaning or data sharing. So there are a couple of different ways, again, to think about these open science communities of practice. Several of them are focused on a particular discipline. I'll highlight SORTI in a minute because they have a conference coming up next week. But others include the Society for the Improvement of Psychological Science. SIPS has been ongoing for about 6 years now, and they have annual conferences that include, I said conference, but really it's an unconference. What that means is that the content is generated by the active community members who engage with it. Unconference sections are discussions about a problem and a possible way to solve it. A hackathon is a group work section where individuals work on a very well-defined question for a period of usually 2 or 3 or 4 hours. It gets its name from kind of like the software development community where you would hack a software tool together quickly. But quite frankly, it's appropriate for any sort of problem that could benefit from 8 people putting their heads together and working on a very defined specific problem for a couple of hours together. And then finally, the STEB Hub for Education Research is an initiative to bring open science practices to education researchers and both provide trainings and content and to develop community through unconference, through discussions, hackathons, and workshops. The other dimension that many of these open science communities exist in are, of course, geographic regions. There are several of these. One of the great ones I'll highlight right now is the reproducibility. For like having a cup of tea. They're British, that's where it started, but now they're located all over the world. And those are journal clubs that simply discuss a topic or two a week about reproducibility or a new process or something along the lines. And there are lists of recommended journal articles and discussion questions and discussion prompts. It's a great way to bring these discussions to your department by starting a journal club like that. There are also recommended ways to do that from the Open Science Community Starter Kit. They have a lot of resources available to that. I mentioned I want to highlight just a little bit SORTI, the Society for Open, Reliable, and Transparent Research in Ecology and Evolutionary Biology. SORTI has their inaugural conference next week. It's a free conference. Of course, it's virtual as we live in these days. And there are lots of great materials and unconference sessions available on version control with Git and RStudio. It's something I haven't talked about much yet, but it's a great way to collaborate on scripted analysis. There are hackathons and workshops on improving computational reproducibility. That means taking a data set, taking an analysis, and being able to rerun that just so we're really sure that the precise steps are very clear and doable by others. Working collaboratively across time and space on similar research questions. There will be a workshop on the what, why, and how of pre-registration. That'll be mine, so I hope you come. And other ones for using R for reproducible analyses. So take a look at that if you are interested. It's obviously geared for ecology and evolutionary biology, but a lot of these are quite discipline agnostic. So if you're curious about that, you can take a look at their program. That is most of what I have to say. I really wanted to spend this time as a way to show what I mean by what open science is, and specifically talk about the tools and the educational resources that are available to figure out where to go next. Because again, as I said at the beginning, it can feel like a huge wave crashing over you and not knowing if you're going to sink or swim. But by getting started with one or two of these, by making a commitment to do one or two of these practices over the next year or two, it can be a great entryway into seeing what benefits this have, both for the credibility of results that come out, but more importantly, the benefits that accrue to you. As Zach said, many of these benefits about reproducible workflows are felt by you a year or 2 years from now when you go to reuse a script or figure out precisely what the heck you were doing a year ago and when you want to build on that work. I said this a couple of times, but let me just reemphasize the fact that all of the resources that we shared are available on this OSF project. We'll be using this for other webinars in the future, so these will be added to. And through the Q&A session, if there are other educational needs that arise, what we'll do is we'll take a look and keep that updated for the next day or two. If questions arise immediately after this, that'll be the place where those get curated. I will stop sharing my screen and we'll go into Q&A mode. I know there are several things in the chat, so I'm going to stop sharing and see what those are.
Thank you so much, David and Zach. That was really a lot of information and very helpful. And that project page is, I think I will be bookmarking that. And that's the latest thing that I've added to the chat if anyone wants to get there again. But just I would love to hear from anyone with any questions. Feel free to raise your hand and we'll give you the floor, or type it in the question and answer toolbox, whichever one you feel more comfortable with. We do have one question so far. The question is, are there consulting services to help do open science for investigators?
Yeah, the first one that comes to mind are often available through university libraries or university data science or statistics departments, and that's the statistical consultant. That is a widespread service that is again often provided either through libraries or university stats departments that are very helpful, particularly in the early stages of experimental design considerations. One of the cliches that they often share with me when we work with them is that folks will come to them, what's the joke, to sort of salvage an already conducted experiment or study and see what can be gleaned from this. And that's often not the right time. So take a look at your sort of university stats or library departments. Those are the best places to find stats consultants and engage with them relatively early on. That's one of the main sort of benefits of including that statistical analysis plan in a pre-registration. We found that that's the longest time that it takes the longest time to fill out that section, because those types of questions are very frequently left until sort of the end of the project. And the active pre-registration not only has those benefits that I talked about earlier, but forces you to kind of stop before data collection or before accessing a large data set and really thinking through what those precise analyses are going to be. So a stats consultant can be a great resource when you get to that page of working through a pre-registration. Is it available internationally without restrictions? So I can say that the OSF is available internationally without restrictions, and we do have servers available in the US, Canada,
Germany,
EU,
and
Australia,
I think.
and that's to help comply with local laws about where research data has to live. stats consulting, that's usually kind of a geographically focused, they'll provide it for researchers, close by, but in today's world, that's a little bit irrelevant. So presumably yes, but most of those are, they're free if you're in the university community, but they're usually a fee for service if you're not sort of directly associated with that university.
Thank you. We also have Florian has risen their hand, so I'm just going to allow Florian, if you can, I see that you're muted, but if you want to ask your question, go ahead.
Thank you very much. I use sciences of complexity, algebraic fractals that I built in the last 3 decades. It is impossible to write an article because it's so complex that it's not a collection of information. It's a huge amount of information that is structured. And if I want to write an article, I should write a library. Thousands of pages. Nobody can read this. It's not possible, but can be understood. I can show you what I'm doing if I have a possibility to show. Okay, when you want.
All right, go ahead, sorry.
But I need a share screen to show you.
Oh, no, maybe can you send me an email, Florian, and open@templetonworldcharity.org,
Yes.
and then we can share it that way. I think that's a better place to do it.
Yes, but still we need to have a share screen to present. It's not possible the other way.
No, it's not possible in this kind of webinar setting right now.
It's no problem now, but for the future.
Okay, great. Thank you so much.
Good.
Thank you.
Thank you.
2 questions in the chat came through from Josafa and Christine. Are there specific plans and design approaches to enhance visibility and communication among researchers in non-weird world settings? One of the great communities is that, and I'll provide a link to that in a minute, or that can take over, that the grassroots network of open science communities includes many communities that are kind of outside the Western industrialized world that connect with resources to share the informational needs and the free to use digital resources in these non-weird settings. And so in a moment, I'll point you to a couple of those communities. There's a really thriving one in Indonesia that's comes to mind very quickly. But there are others on that network that discuss issues about translating these weird specific resources to more globally representative resources and availability. Christine, most of these resources that we've pointed out are available free to use. So let me just describe OSF in general. OSF is an open source, free to use platform. It has file storage of 50 gigabytes available for publicly available projects, or 5 gigabytes for private projects. And those are, and all the tools and resources available on OSF are free for individual researchers to use. We work with institutions in various different ways to create branded or sometimes discipline-specific resources, and we work with them to support the services that are provided to those institutions or communities, but they're always free to use for individual researchers. The other ones, OER Commons is a platform that's also, it's a platform that's paid for through their business model, and we're supported for that through an NSF grant. But joining that community and finding resources and submitting resources is again free to use. Most of the trainings that I pointed out, especially the self-directed ones, those online courses are free, and the ones I particularly pointed out have some of that sort of good evaluations and back and forth that make it more engaging than just sort of reading an article. But all the self-directed trainings and the articles that were pointed to, those are all either open access or free. The workshops that usually require somebody coming and providing a training, those are almost always require a fee to support the time or the travel to support that network.
Yeah. Thinking of the next question of what kind of data can be shared in terms of raw or processed, it will depend what kind of data you're working with, because if you're working in a context where you're collecting sensitive information about human participants, you may not be able to share everything in its most raw form. But I think the kind of general orientation is to share the most raw form that is both ethically and logistically possible to share. And so to the extent that your participants have consented to share their data, I would encourage you to share individual responses, generally de-identified. So removing things like IP address, email address, names, that kind of thing. But like I said, it is generally context specific. So depending on what kind of data you're collecting, just be mindful of what the potential danger to sharing that information might be. And also consider if you are collecting data that is sensitive in some way, there are plenty of ways to de-identify or even aggregate that data so that you can still share some version of it and share a more processed form that still provides others with the data that you've worked with, but not in a way that's potentially harmful to participants.
One of the resources that were available on the data sharing section of the wiki really gives some appropriate prompts for like what you should be considering early on for sharing the data. And it actually reminds me, as Zach was speaking, there's another resource that's quite helpful, template language for including in informed consent or in ethics review IRB panel language. One funny bit of inertia that exists from the old days, so to speak, is language that says we'll never share your data for any purpose, or the data will be destroyed after 5 years, sort of stuff like that. That's kind of overly conservative. Their surveys of research participants generally find that there's sort of a desire for that information provided to be shared in a very ethical way that doesn't risk their confidentiality, but that does go for maximum benefit of the research community. And there are best practices for making sure that that decision is made in a very informed manner, so that informed consent is not just a superficial description, but is truly internalized. And language to make sure that ethics review panels can see what type of data are going to be shared and how it's going to be preserved. So I can add a couple of those examples to that wiki, along with that sort of a couple of staff consulting resources.
Thank you. There's another question in the chat. In the Bahamas, we are just launching our first ever National Statistical Institute. We, like many Caribbean nations, have historically struggled with the concept and culture of open data. What are your thoughts about how we might best integrate open science resources into such an institute?
My first reaction is to think about the benefit that it'll provide in conducting this in a purely internal fashion first. So a lot of the kind of benefit of open science comes from the expectation that somebody else will be looking at this later. But that can be, but that thinking can be applied even kind of as you sort of internally think about what's going to be the most fair and appropriate way to grapple with these issues of essentially kind of like data colonization or issues that relate to that. So think about how kind of internal collaborations within a statistics institute can lead to the same type of reproducibility that could be seen globally. And so partnerships between labs within an institute can be a good way to mimic a lot of the benefits that open science was kind of designed to address, while grappling conscientiously with those with that other issue too. That would be my first. That's my first. Do you have anything that built on that? I think that's the best as I can say.
I think my orientation is very like hit the ground running with very practical applications. And so I would encourage thinking of bringing together resources that are specific to open science. And so you might take some of the things that we've highlighted on the OSF project that we've shared so that others have kind of that entry point to engage with open science that you can curate for wherever your focus might be. And then also, to me, I think for statistical institutes, especially, becoming comfortable with version control is just a very practical step that is very impactful once you get into the habit of implementing it.
Yeah, thinking of like the menu of options in open science practices and thinking of the one that will have the kind of the most immediate kind of internal benefit. Version control is a good example of like, this is just a, it's kind of one of the issues and topics that fall into the open science umbrella, but really it's not about open science. It's about sort of project management, internal consistency of how issues are dealt with and improved upon in sort of a difficult analysis pipeline. So those, that would be kind of one of the first items to choose from the open science menu, so to speak, that don't touch directly on some of these broader issues. And then, later on, you can sort of figure out what's appropriate to tackle next.
Thank you. We don't have any other open questions. But I think you also want to take the time to see if there's any other resources or help that people needed on, so they can add it to the, oh, a raised hand is up. Sorry. Thanks, Virginia. Okay, sorry about that. We have one more. Okay, you should be able to. Professor Kamara? I think if you unmute, you should be able to speak or ask your question. Maybe I waited too long. You can maybe add your question to the chat if you're still there. Okay. Okay. All right, we'll see if the question comes up. But I guess we're also opening the floor to hear about if there's any other assistance that other people need. Right? Okay. I mean, it was very comprehensive, so perhaps you've covered everything. Okay. All right. Well, is there anything else that you two wanted to add, or should we maybe close off a little early?
I have one last thought on this previous question about kind of where to start. I think something that we've mentioned is that there's kind of a wave of information when you start getting into open science and trying to integrate it into your own research. And I think it's important to remember that it's just a new skill and habit, and so just starting somewhere and building off of it is very reasonable, and you don't actually have to be the perfect open scientist when you start doing open science. And so just starting somewhere is actually the best place to start, and then just exploring more as you go.
Yeah, absolutely. Don't let the perfect begin enemy of good is a message that I give very frequently. And we've seen, I'll come back to the pre-registration example because it's high on my mind all the time. We've seen thousands of questions come in through pre-registration questions and comments. And it's always the first one takes some effort, and then there's a dramatic improvement the second or third time you do it. And so many times, most of these sort of just take figuring out which is most exciting and then deciding which one to act on first. And as you sort of struggle through it, you'll search for the right answers, search for the resources that can be quite helpful, and hopefully we've provided you with a good starting place. So to be your first place to look for when you are struggling with that first question with considering your first shared data set, or starting with scripted analysis or version control or pre-registration or preprints or any of these crazy things.
There's another more specific question on whether or not there's any sort of Portuguese/Spanish platforms for collaboration and learning more in open science that you know of.
So I know that the top guidelines have been translated to both Portuguese and Spanish, so I can provide links to those. Just give me 1 minute. And though it's the top guidelines are a set of recommended journal policies to include for applying open science in the publication process, but they're written as instructions to authors, so they provide sort of specific recommendations for how to share a data set, where to go to look for reporting guidelines, what to include in a pre-registration. And so those are, I'll put a link to those. Okay. Those would be a pretty good place to start. This is Portuguese. And then here it is in Spanish.
Okay, thank you. All right, so I think we'll maybe close a few minutes early, 6 minutes early. I just want to thank you both so much. This was extremely helpful for me as well. I think, like I said earlier, I'm going to bookmark this project and go to it. So just to say that our next event on the series is on August 12th, and we'll be delving deeper into one aspect of it, which is sharing the research articles, particularly research articles. The link to this register this event, I'm going to add it to this chat if my screen wants to show. And the recording for this webinar will also be on our website in a few days, which is open science. I'll add it to the chat for anyone else who's still here. But thank you so much. It was really great, and we really enjoyed the time with you both.
Have a great morning and afternoon.
Thank you all so much.
Thank you. Thank you.